Hello, this is Pat Kelly. Okay, in this problem, they give us a differential equation, and they're asking us to determine if it's exact. Okay, so here's the work we're going to do. To begin, I want to get a label on a couple of things. If a differential equation has the chance of being exact, you want to be able to identify what we call capital M, which is actually a function of x and y. So m of xy. And you also want to be able to identify what we usually call capital N, which is going to be over here for me. Capital N, also potentially a function of x and y. You want to get a handle on each of those because those will be involved in the work that we do, the test to see if this is going to be exact. In order to determine what your m is and what your n is, m is just everything that's being multiplied by the dx. So find your dx, and everything being multiplied by that is m. Similarly, find your dy, and everything being multiplied by that is your capital N. Okay? Now that you have a handle on those, the tests that we do in order to see if this is exact is we have to check to see if the partial derivative of m, but, and I'll say but there, because this partial derivative is going to be with respect to y, and the but is that, remember, m was the expression tied to the dx, but you're doing your partial derivative with respect to y, just for this test. And we want to see if that ends up equaling, and you do your partial of capital N. Similar thinking, though, with the but. The n expression was tied to the dy, but we're going to do our partial derivative with respect to x. Okay? Keep that straight in your head. Get yourself set up for success in terms of checking to see if it's an exact differential equation. This is a question mark, though. We need to see if those two expressions are the same. So let's do that work. So in my next step down, I'm going to do the partial. Let me slide over, make sure I get enough room. The partial derivative with respect to y of, in my capital M, let me leave some space. I'll try to keep it color-coded even, because I have that in orange there. So this capital M is my expression x sine of y. All right? And we are seeing if that ends up equaling the partial derivative with respect to x of, what color did I have? Pink. So my capital N is the expression here, x cosine of y. Okay, and still going with my colors. That's still a question mark. I need to see if those two guys equal each other, okay? All right, hopefully you remember. I know you remember your partial derivatives. If we're differentiating partial derivative with respect to y, you treat x as a constant. So this is really just a coefficient. The derivative then, I'm focusing on the derivative of sine of y, which is cosine of y. My coefficient, if you call it that, stays there. So I end up with x cosine of y. I'm done on the left side. On the right side, partial derivative with respect to x. So I want to keep y as a constant. So this cosine of y becomes like a coefficient. The derivative of x is just 1 with respect to x. So this is cosine of y. And I do still have a question mark here. Can you answer it? Does that left side equal this right side? Close, but no cigar, right? So no, a big old X. My answer, let me slip over here, is that this differential equation is not exact. Okay? If those two partial derivatives were equal, your answer would be yes. All right? Go try some more on your own.